Okay, guys, so let's start. So good morning, everyone, and thank you for skipping the breakfast, the coffee break to being in our session. I know that this is really important. My name is Diego Akeshi. I'm the engineering manager for HA extension and SLES for SAP at SUSE. And here with me.
Yeah, my name is Xavi. I am an engineer in the HA team called SHAP team. That is a combination between HA and SAP. I think it's a quite good name. So let's begin.
Yeah. So today we want to show you one new open source project that we started with the main intention of reduce the time and the workload to deploy a HANA cluster. So we mentioned public clouds here, but of course partially some of the components you can use for bare metal. So we will try to cover this during the presentation. Of course, it doesn't work.
Yeah, work.
Okay. So, yeah, we are celebrating 20 years of collaboration, or even more, 20 years of the Linux Lab. So we have some colleagues from the SAP Linux Lab sitting here today. So our success on the SAP business doesn't come for free. So we have worked a lot, and we will probably continue to collaborate a lot in the future. So, and we are really proud of it. So yeah, we consulted our crystal ball in the morning, so I'm pretty sure everyone here is having some questions. So who here is already using SLES for SAP and the clustering? And who is here because wanting to start to use it? Okay. Yes. I saw some people reacting, so so this is important to clarify. I will not cover all of this, but it's just to remind you guys that SLES for SAP is a combination of services and features and software. So we have integrated on SLES for SAP. We have, of course, the SUSE Linux Enterprise Server, but we do get there the HA high availability extension, the specific SAP tools. So you probably heard things about the wizards we have, the SAP Tune, SAP Conf, and other things, but we do also get a better support. But to have more details of this, I will invite all of you to visit our technology showcase, because the guys there can cover box by box here. I want to give more time to talk about the technical part. Okay, so I think a lot of times we talk about the HA extension, but we don't really do much details, or sometimes we don't really cover. So I want to give you guys some ideas that our HA extension, when you buy SLES for SAP, you receive the entire extension. So not only SAP specific, so you have much more capabilities there than only the SAP specific clustering features that we have. So integrated on the HA extension, we have, of course, PCMaker, the resource manager. We have clustered file systems, so OCFS2, GFS2. We have resource agents specifically for clustered Samba. Our solution is virtualization agnostic, so that's why inclusively, because it works on public clouds or in bare metal. We have full support for different architectures. In the SLES for SAP specific case, it's only supported for Power and Intel. But if you want to have the HA extension purely, you can also have for Z. You have a load balancer, so I think HA proxy tells by itself. It's very famous. You have data block replication, disaster recovery with REAR. You have Hawk Web UI, and more than 100 research agents and face agents. So it's more than only SAP features. And then you can combine these and use for different purposes, but of course for SAP as well. Okay, important to note that all the HANA system replication resource agents that inclusively what we're gonna show today, they are only available for SLES for SAP. Okay, so if you buy the HA extension, you don't get this. So this is only available for SLES for SAP product. Okay, so yeah, but what about SAP? So what exactly SLES for SAP can do for my landscape? So why should I use HA or. So I will not cover this with deeper details. We have a session tomorrow handled by our colleagues Bernd and Fabian about this, so they will cover with deeper details. But it's important to note that we have cluster solutions with automated failover for S/4HANA and NetWeaver, so all the application server layer for the many different scenarios. They will explain a lot about this. And we also have for the many different purposes and scenarios of HANA. So starting from the scale-up performance optimized scenario that we will show today, to cost optimized, scale out, and multi-tenant database containers and so on. So all of these with automated failover and near to zero downtime. So this is the term that we use to present how our clustered solution behave together with SAP HANA. And I really invite you guys, if you're not familiar with this or with those capabilities, to visit the session tomorrow to get more in-depth details about that, okay? And, okay, really important. All of this works on premises, so your bare metal application, but also it's available and working on public clouds. So it will really help you to do transitions. So if you are willing to go to hybrid, or if you are willing to move your production to the cloud but still needs to remain on premises, all of this works in a very similar way in both scenarios. So that means you don't need to train your team again. You don't need to gather a lot of new knowledge about our tools itself. You will, of course, you need to understand how the public cloud works, the features that you have there, but it reduces a lot the curving, the learning curve that you have for do such a transition, right? Okay, so I think we covered the commercial part. So I think all of you are here to talk about technical stuff. So I will hand over to Chabi.
Thank you, Diego. You did it faster than I thought. Yeah, enough of marketing. Let's jump to a more technical content. Here we are talking about Terraform, about Salt, but specifically as well about SAP HANA and HA extension, okay? So as Diego questioned before, here we have already some SAP HANA users. So one of the first motivation before starting this project is that when we start in the first time trying to deploy the SAP HANA cluster and the HA station, we face several issues during the process. So that's why we started thinking about how can we make this easier. Okay, let's jump. And this is the major motivation. Right now, we find that there are some complex steps when we are trying to deploy the cluster, and it's not really user-friendly. Actually, we have several ways of doing that. We have an installation wizard, we have several bunch of commands, we have CRM shell, we have many things. But even though we can make mistakes, okay, there are several files that we need to change, several things that we need to do, and we can make there some fatal errors, okay? So one of the things that we want to avoid is this, okay? The process is quite error prone, and we want to avoid that, having everything automated. So yeah, if you listen to me all the time saying automation, this is one of the key points about the project and about the session as well. Another thing is that to make it faster, okay? We know that when we start first time deploying SAP HANA and HA, it takes time. It goes from 1 day, 2 days, until to a week. So we want to improve that. With that, we don't want to just replicate the manual deployment, because it's important to know how it works behind the scenes. We need to know what system replication does, what HA does. But after that, we want to give as well other options to deploy. Not only for the final customers, for the final users that might be sales engineers, support engineers, even the developers that they want to have a cluster deployed in minutes, okay? And that's it about this slide, so let's continue. Yeah. And why we chose Terraform and Salt. Here I have some details about Terraform, but the main point and the one that I want to highlight is that Terraform works as an infrastructure, as a code. That means that we can write code as or declare the infrastructure in some files using Terraform. For example, I can put that I want to have two instances that they will be just the nodes hosting SAP HANA, like the primary and the secondary. I can declare other support server to hold or host a SCSI server. I can declare the network. I can declare that I want to have public IPs, etc. So this way, what I avoid is the need to create this manually. In fact, there are several options. If I want to do it, for example, using KVM, I need to know about KVM. If I want to do it in AWS, I need to know about AWS. If I need to do it in Azure, I need to know about them. So with that, we want to make it everything the same, just changing some different points in the deployment configuration files. And after that, everything should work the same way for all of the providers, okay? Besides that, Terraform gives us the option to make just modular blocks. This way we can reuse these points in other projects. But this goes beyond this presentation, so the Terraform is quite a big monster. It provides us a lot of functionalities. So let's jump to Salt.
Yeah, I think it's important to notice that when you talk about infrastructure as a code, we talk also that you can version your infrastructure. So imagine that you can version it, you do changes, apply it and say, oh, it didn't work or didn't work as expected. So you can revert this, try something different. So it gives a lot of power to improve your infrastructure in a more and very more secure way.
Yeah, basically at the end it gives you the option to replicate one concrete part, okay? If you have already versioned this particular scenario, you can save it somewhere using GitHub or whatever repository you want, and you have it all forever, okay? In the future, if you want to change it, you are able to change it. But if you want to go back and reuse what you used before, you are able to do that. So this is one of the options that gives you Terraform, okay? And about Salt, there are many sessions about Salt here in SUSECON 18, so I won't go deep. But basically, we use Salt as a configuration management system, okay? At the end, Salt, what provides us is to arrive to a state that we want to arrive, okay? At the end, it runs a bunch of commands, but they are not just executed plainly. They have some logic behind. So the idea is, right now we are here, for example, in a machine that we don't have SAP HANA, and we want to arrive to a state where we have SAP HANA installed as a system replication enabled as a primary. So Salt, what we will do is it will check the initial state and it will say, okay, I don't have SAP HANA installed, so I need to install SAP HANA and I need to enable system replication. So it will do all of this path. If we have already SAP HANA installed and we want to add system replication, we can do it because we are telling, I want to arrive at this point. I don't want to do this, and this. I want to arrive to this state. So it's important to know. We will see a word that is mentioned several times, that is idempotent. I don't know if I pronounce it properly, but it means that at the end we will arrive to a state always. It doesn't matter the starting point. The final goal is to arrive somewhere. And that's it. Besides that, obviously, we have a lot of other features, like we can run Salt remotely. We can create even a cluster having a master Salt and minions in order to have everything stored in the master, and many other features, okay? So this is the combination we selected. More than that, because Salt is one of the tools that we are really committed in SUSE. We are contributing, and in fact this project is contributing to Upstreet's Salt, so it's important to mention. And this is where they match, okay? We use Terraform, as I said, to create infrastructure, and inside Terraform we run Salt to make system management, okay? And at the end, this is what we are achieving, and this is our final goal, okay? So at the end, as I told you before, is to reduce the deployment time from days to hours, okay? This is important. And to arrive to idempotent states, okay? To have always the same final state. It doesn't matter the starting point, we always want to arrive to the same state, okay? This is what we declare in Terraform. And that's it. Besides that, we are talking mainly here on Terraform, but everything we are doing in Salt can be used in other scenarios, like SUSE Manager, in the future maybe Just, or even in your own custom scripts, if you want to use Salt plainly.
Okay.
Yep.
We're going a little bit fast, so do you guys have any questions so far, or everything's clear?
Yeah, anyway, we will do a demo later, so I will try to do the steps slowly to give you an option. Anyway, we are there in the HA booth if you want to come and see how it works and to go into details, okay? And yeah, as Diego mentioned, we are trying to work on-premise, using virtualization, but mainly in the public cloud, okay? This is what we want to achieve because we are seeing a trend that the migration from bare metal to virtualization is going through the cloud, so it's important at least to provide this option. Right now we are working on those, maybe Azure, AWS, Google Cloud, but we have plans to add OpenStack, maybe Alibaba in the future, who knows, okay? So at the end, this is the power that Terraform gives you. There are already the plugins done.
There's a question there.
Is it going to work with SAP HANA?
We haven't done it yet, but we can put it in the backlog as well to try to make it work, okay? Right now we are focusing in SAP HANA mainly, and in fact in Perform.
SAP Hack is the HANA cloud.
Ah!
Yeah.
Okay, maybe Diego, you can answer better.
More the traditional host.
Yeah, so we have our roadmap, other cloud providers, but this is under discussion because we needed to start somewhere, and those are
the most
the
popular.
starting points that we took. But if you have more use cases, or I would like to listen more from you guys. I would be really interested.
I would have a question. I'm not familiar with Terraform, but I understand the software-defined infrastructure that's depending the Terraform support. That means each cloud platform supported by Terraform is also supported by SUSE.
Yeah, each cloud provider has its own plugins that they make use of their AP REST application and so on, and basically Terraform wraps everything. So it goes to the provider's plugins and it works this way,
Yeah.
okay?
Terraform is a common layer between the providers and the different platforms. So it gives you an orchestration framework with a common language that you can define a very similar way how to create a node on Azure, on AWS, and Google Cloud. So you can very easily create layers where you can only change, for example, the low layer for the provider that we are using without sacrificing the others layers. So it gives you the opportunity to have more flexibility when migrating to one provider to the other. That's different when you use the cloud API itself, for example. Okay.
Yeah, that's the magic at the end behind Terraform, that we can have like generic models like HANA instance, and behind that just spread out instance for Azure, instance for AWS, but at the end they work the same way, okay? Because we are only using that generic part.
And maybe a short addition to that, so the HANA Enterprise Cloud, as far as I know, is running with Xen hypervisor, right? And if it's running with Xen hypervisor, it's using libvirt, and then basically the interface, the common interface of the libvirt.
Yeah.
So basically run with HANA Enterprise.
Yeah, in fact, there is a particular plugin for libvirt that just uses KVM virtualization on commands and so on. So, yeah, it depends on the provider, but this makes you this transparency for the final use.
Okay.
What about OpenStack? Is that something supported?
It's in our, yeah, OpenStack is supported by Terraform. We haven't then started working in that, but it's in our backlog already. So it's on the future of this project, okay? But yeah, it's totally supported by Terraform. So at the
Yeah, let's say we call this Lego kits or building blocks. So the idea is that we really have the freedom to even combine them. I don't know any use case like this, but Terraform and those components could allow you, for example, to deploy one node in one cloud provider and the other node in a different cloud provider. But this, don't take this seriously. It's just extrapolation, okay?
Yeah, okay. We cannot promise that yet.
Yeah, but it's basically as flexible as it looks like. So, and of course, we want to enable more providers. And more than that, it's an open source project. So if you guys want to take it, use it, you can even contribute back. We're very helpful. We are happy to receive ideas and contribution there. It will be merged for sure.
Exactly. Thank you, Diego. So just before going with the demo, I want to explain a little bit about the architecture to make you understand how Terraform and Salt work, okay? So in the lower layer we have, in this case, Terraform, because the session talks about Terraform, but we could use any kind of way of creating infrastructure. We can do it manually, we can use AutoJust, we can use SUSE Manager, or etc., okay? So at the end, what we want to expose is that the Salt part is totally modular. We can take it, grab it as a box, and put it other way, okay? So it doesn't necessarily, it is not necessarily created just for Terraform, okay? And this is the Salt part. The first layer is Shop Tools. Yeah, the name makes sense about our team. And it's basically an API to manage SAP HANA, okay? It runs SAP HANA commands just using Python. We have chosen Python because it's the language used by Salt. And at the end, it interacts with HANA, okay? We have there all the commands like install HANA, enable system replication, register secondary node, and so on, so on, so on. Then we have the execution modules. And at the end, the Salt execution modules are a piece of code that wrap the lower layers, okay? In this case, Shop Tools. What's the benefit of having execution modules? That you can run them in Salt, okay? You are not needed in this way to know how Shop Tools work or how Python works or etc. If you have Salt working, and if you have this code imported, you can wrap whatever you want with Salt, okay? Anyway, this is kind of maybe complicated for this session, but I repeat, if you want to know more, you can come to the booth and check how it works. Then we have the state, and coming back to the idempotency. The states are the piece of code that make the logic, okay? They run the commands, but they run the commands going through different paths. They initially check, okay, where I am. I am already in this position, so I need to do this, or I need to do this. And they will go through a path until arriving to the final state. And in the state, they will execute, okay, I am right now in the state that I want, and if everything went good, they will say, okay, yeah, succeeded. Well, we can continue. Otherwise, it will raise an error, and it will say, this happened because you configured wrongly, the parameters you set weren't working, or SAP HANA installation folder wasn't found, okay? There are several ways that a state may fail, but at the end, the purpose is to know we will arrive to this state, okay?
Yeah, well, one good example, we have a state called HANA installed.
Yeah.
So the state will check, there is a HANA running with this system ID, with this instance number. Yes, I will not do anything because it's already installed. No, there isn't, so it will install HANA, okay? So this is an example. So it is smart enough to not change something if it's not needed.
Yeah, we want to avoid to reinstall SAP HANA if it's already installed. You know that it takes some time.
Well, and you can lose data,
Yeah.
so.
And finally, the formulas, okay? The formulas basically are the place where we gather all of the states and we make like the big part of the logic, okay? For example, a formula could be deploy SAP HANA. At the end, what it does is it checks, okay, after providing this information, I will install in this host SAP HANA and I will put system replication as a primary, and in this host, I will install again SAP HANA and I will enable or register the second host as a secondary, okay? And we put all of this information on the formulas. At the end, they take all of the pieces of the states and combining them, they make like a bigger purpose, okay? So that's the idea behind the formulas. We have already created two formulas, one for HANA and the other for HA. They are totally independent. So if we only want to use SAP, it's okay, we can use the formula. If we want to use HA only, okay, the formula is available. And if we want to combine them, we can use both of them, okay? So this project uses both, but the formulas are totally public. You can download that and you can use them whatever you want, even if you want to use for SAP or just for HA, okay? Yeah, let's continue.
Yeah, I think the last layer tells for itself, so it's the integration. So the usage of those tools also allow us, for example, to integrate the formula from SUSE Manager, from YAST in the near future, but also Salt itself provides APIs, so you can integrate on your own scripting, you can integrate to your current existing dashboards or current existing pipelines of deployment and so on.
Yeah, at the end after the demo, I will show you some screenshots, or actually SUSE Manager running, and we will show you how we can use the formulas there.
Yeah. So important to note that the blocks are independent. So if you only need the API, you can use only chat tools. But if you need the full deployment, you use the formula. So the idea is that we decouple this in a way that you can really take advantage for your needs. We know that not company is the same, and the use cases are very diverse out there. So We are humble enough to know that we will not cover all of them, but we want to deliver something that covers 8 or 9% of the boilerplate part and give you the power just to tweak for your needs, okay?
Yeah. Okay, so let's jump to interesting stuff. I hope so, Ali. Okay. So, first of all, some propaganda here. This is the GitHub project that we are using right now for the deployment, okay? It's totally available in GitHub, so you can check around and see how it works. We are trying to put everything on the README files, okay? So we think that it's quite easy to follow, but we have already found that we have several issues. It's not the same the user point of view from the developer point of view, so just feel free to check out. And I will jump to the editor, okay? Okay. Can you see? The font size is okay? Okay. So basically this is the project, okay? We have splitted the providers in several folders. This is maybe small, but we have one folder for AWS, other for Azure, other for Google, and other for Libvirt, okay? In the future, we want to have here OpenStack and other options, okay? And then we have other shared folder that is called Salt, where we have all the logic of Salt, okay? And this folder works for all of the providers, okay? At the end, they use this folder. And what we have to do is quite simple, so I want to make it easy. So the idea is to only run or execute 3 steps, okay, in order to use this project. The first one is that we need to create some SSH keys, okay? These SSH keys are used to make the communication between the 2 instances available, okay? As you know, in order to enable HA communication, create a cluster, join to the cluster, etc., if we don't have this SSH keys shared, we are forced to add a password. So in order to avoid that, and because most of the times in the cloud we create the instances just passwordless, so we are forced to create the SSH keys. And we have to just put them here in this folder. Again, if you want to know more, come to the booth, but this is really basic. We use some SSH command, SSH kgen or whatever. We create the keys without passphrase, and we put them here, okay? Then, second step, we have the pilar files, okay? If for the people that you are not familiar on Salt, the pilar files are just configuration files to put there the sensitive information or the configuration information, okay? As you know, in SAP HANA and in HA, we have a lot of information that we need to input. If we run the commands manually, even if we go to SAP HDB SNUtil commands, we need to put there a lot of names, information, host name, etc. So at the end, if you are used to make it manually, here we need to put all of the information that when we follow this process, okay? For example, and in this example, we are just composing a cluster with 2 nodes, okay? Here we have the main entry that is nodes, and we will have a first node declared this way and a second one this way, okay? And we have to put here the more important information, okay? This is just the basic information about SAP HANA installation. We need the system identification, the instance, the password, etc., okay? And then we have some additional entries. In this case, install, that is optional, okay? And means that we want to install SAP HANA, okay? And here we put some extra information. Here, this is the mandatory information. We can add extra information to customize the configuration file, but with this it works, okay? So in the future, if you want to have more particular SAP instance deployed, we can change whatever we want. And obviously, even though we put install here, if the machine has installed SAP HANA with these parameters, it will avoid the execution of the installation, okay? This is important to know. And then we have the second optional entry. In this case is that we want to enable this host as a primary site, okay? And the same, we need to give some important information as the name. Here we are saying that we are to backup the current database, okay? And to create a user key entry. Those things are the things that we are already doing. They are exposed in the guidelines, so at the end it's exactly the same. And we repeat the same with the second host, okay? we will have the same information. As you know, we need to keep the same information to make system replication available. We will say that we want to install SAP HANA, and we will set the information of the secondary side. The same. I want replication mode async. We can put here whatever we want. If we want to make it async, we can do it. Here the same. And we have an extra parameter here, primary timeout. In the case that the secondary is deployed first, obviously it has to wait until the primary is enabled. So here we are putting like 3,000 seconds of active pooling, okay? And this would be about HANA. Obviously, you can use this. I mean, you don't need to use yes or yes HA. If you only want to install SAP HANA, this is available, okay? But besides that, if we want to add the HA extension.
Well, I don't know how visual it is, but if you only want to install HANA, you just remove the primary lines and those steps, and then the formulas will ignore it, so it will not configure any system replication, okay?
Yep. And let's jump to the cluster. That follows more or less the same infrastructure, okay? For the persons or the people you are familiar with CRM shell and the commands you need to execute, SVD and so on, we are putting here the exact same information. The name of the cluster, where the cluster will be started, in this case in HANA 01, we could put there HANA 02 or whatever. The interface that the uses, in this case we are forced to use unicast because it's the only unique way in the cloud. The watchdog, the SVD device. This SVD device is configured by Terraform, so in this particular moment it's hard-coded, but if we have a device or whatever, it will work. I forgot to mention that we will deploy 2 instances to host HANA, but we will have other third instance just hosting a SCSI server, okay? So this device is just directed there. Then obviously, because we are using SAP, we need to install this resource agent. If we are not interested in SMP, we can use the cluster without this resource, okay? And we can put then whatever we want. And then finally, in order to import all of the configuration of the resource agents, we can use different options. In this case, we are using one already configured file that will create the resource agent configuration for the performance optimized, okay? Our idea is to provide all of the templates for all of the possible scenarios, but as the most typical usage for us is performance optimized, we have this.
This is a Jinja template, so who is familiar with Python? So you can inject your own resources configuration, you can adapt. So those are all parameters of the formula. So if you want to deploy a different cluster, you just create your own.
This is the same of Subtune or SubConf?
No, this is about the clustering part. Subtune and SubConf are utilities for tuning the system. So they are part of the deployment, but it works in different ways. So they works as a background tool to do the tuning of the system individually for each machine.
Yep. And finally, some particular parameters for the cluster, in this case for SAP HANA. For example, the virtual IP, if we want to activate the preferred takeover, auto-register. Here we are trying to follow the official guidelines. For example, we have disabled the auto-register option. So in the case that we have to migrate from the primary to the secondary, because we had an issue, the registration won't happen automatically, okay? So we have to keep in mind this.
What is in the source? The part of the source?
The source is a Jinja template where we have the information about all of the resource agents. Do you know when you are deploying SAP HANA at the end, in the cluster, you need to put a lot of bunch of lines saying that I want these resource agents, I want these constraints, I want these parameters. So all of those are just put in the same Jinja, and so the most sensitive information is replaced by those information, okay?
Yeah, if you
Scale up deployment, what you are doing right now? Like scale up HA?
Yeah, scale up,
Yeah.
performance optimized.
Yeah, 2 nodes identicals with full sync between them.
What I'm trying to understand is you have just mentioned one resource agent. SAP HANA SR, what about the IP agents or HANA?
It will be configured.
It's a package.
Yeah, it's a package, but it's a part of this. It is already installed via the formula determines a list of packages, including a pattern. So there is a pattern called
Yeah, one of
SAP HANA or pattern, something like this. And this will install the resource agents package where you have the IP address too and the other resource agents needed. So that's why we skip it, because it's already abstracted on the formula itself.
Yeah.
But here you can configure your the other things that are not installed by default. So you can install, in this case, SAP HANA SR package, but you could install your own resource agent or any other package. Okay? Because okay.
Yep. Okay.
So what the source we're going to do is basically a CRM config upload. So it will import the Jinja, of course, to replace the.
This goes. This is the Jinja, okay? Basically, here we put all of the resources that we want to create, okay? Usually we have to do this copy pasting on the console, whatever. Here, we put everything here and we load the configuration, okay? And the idea of that is to have other templates for cost optimized, scale out, or whatever we want. Okay? Cool. And the last part is to configure Terraform, okay? Obviously, Terraform doesn't go so deep about SAP and HA, even maybe it doesn't know about that, okay? So we need to add other extra information. And to Terraform, we have to give the information about the cloud providers in this case. For example, we have to say how many instances we want. In this case, as we are using just scale-up performance optimized, we are going to use 2 instances. We are going to use this kind of machine. This particular example is for Azure, okay? If I didn't mention before. But it's almost the same for AWS, okay? So all of the parameters are the same.
Yeah, so the most basic information about the cloud or the provider that you want. So the size of the machine, the image that you want to use. So in our case, we are using SLE15 and SLE12 as before. And many other things like your reg code to register the system, to have access to the repositories, the region where you want to deploy it, and so on and so on.
Yeah, here some information about the storage account, where we have all of the SAP HANA installation files, okay? So we need to have a storage account there in our Azure account, and here's some information. Obviously, I have replaced them in the deployment, but we can tell you how you need to manage. Some other information. So I told you before, here we are saying where HANA will be installed, and all other things, okay? And finally, this is maybe the most confusing part. We have these 3 entries that are the HA site deployment repo. Is the repository of SUSE that we use to download the packages, okay? For example, the formulas are stored there, and usually we will put here the HA factory repository. The idea is when we put this as a product, this should come in the SUSE Customer Center automatically, and we could download this project, okay? And then here we need to put this information about the registration code about SUSE Customer Center and the email. And that's it. We use that in order to download the packages. Okay, as I told you before, we are using the patterns, so we need this information. And that's it. So how it works? In order to deploy, I am already on the folder, okay, of Azure. I have already copied these files and everything in this project. So everything I need to do is just run these commands. In this case, I will run the deployment, but it takes 1 hour. I have other cluster deployed, so I will show you the final result, and we will make a failover later. Okay? Okay, so basically what we need to do is just initialize Terraform. This is used only to download the plugins and etc. about Terraform. It shouldn't take so much. Other thing that we really recommend is to create a workspace. A workspace basically is a place where you can customize your deployments using the same folder, okay? If I don't want to change or download again the repository, I can create one workspace, for example, for demonstration, other production or whatever, and I can use them just in the same product or in the same folder, okay? So for that, what I can do is just demo. I have to choose this workspace, And if I run plan on Terraform, it will say me all of the infrastructure devices that would be created if I would apply the final execution, okay? In this case, in Azure, we have a lot of components because we need to create the resource group, the public IPs, the NICs, the machines, the support server, and so on. It takes some time. I don't know, some network issues maybe. Okay, yeah, that's it. Okay, and it only explains what would be created in the case that we finally decide to go on. For example, we are going to create a virtual network with Azure. This is the iSCSI support server, etc. Yeah, you need to know how Terraform works, but we can skip this point, okay? If you are most interested only in applying, okay? So basically, I will run apply. I will put this other extra option in order to skip some questions that Terraform does, and that's it, okay? So this will start working. Initially, it will create the infrastructure, and when the infrastructure is created, it will execute Salt, okay? So at the end, after 1 hour, more or less, in Azure, we will have the cluster deployed, okay? So that's it. So we will jump to the final result that I have here. Okay, so at the end, we will have 2 machines, okay? We can connect it via SSH, okay, it's simple. And besides that, we have Hawk as well deployed. Here. Okay, this is what you should see as well if you do it manually or not. But in this case, everything is done automatically. We have all the resource agents, etc. So I will run a failover just to show you that the deployment worked, okay? Besides that, we want to provide with this product other script that we are using still in development, but it's really helpful that just gathers all of the functions that we use regularly to monitor how it works. For example, CRM Mon, the commands to check the status of SAP HANA, the state, the status, to dummy the database, etc. So here you can see that we have all of the resources. Basically, this mirrors the same that we see in Hawk. Okay. For example, if I run status, this is what we have, okay? System replication working. So the same that...
Yeah, it's active and sync.
Okay, and for example, if I run this, this is the result of some SQL commands there. Okay, so right now I will create a scenario where we need to fence one of the machines. So for that, I will kill one of the process of SVD that is called Inquisitor. That will say to the machine that, okay, I am seeing something strange, I will commit suicide, and we will start the migration, okay? Okay, as you see, SVD detected that something went wrong and committed a suicide, okay? So right now, if we go back to Hawk, we will see all of the migration working, okay?
Can go to the dashboard. So we see that the HANA 1 is gone.
Yep.
And the cluster should react and migrate everything to the secondary automatically.
So this is the typical use case, okay? When one machine fails, we need to migrate everything to the secondary and make the secondary as a primary, okay? And this is done by the resource agents at the end.
Yeah.
Question?
Do you handle or set up Azure load balancer to all of the server?
Yeah, the load balancer is set up during Terraform. Terraform creates the load balancer, and we set the virtual IP to use the same IP address of the load balancer.
Okay, it's just when you do a failover, they do log Azure, but they track the tool.
Can you repeat the question again?
Yeah, the problem is you still points to wherever you were.
Okay.
It means to probe
Uh,
and port.
yeah, specifically for Azure deployment, we use the load balancer, so they recommend to use a load balancer in front of the cluster. Sorry, and there is a small service, or a small resource agent grouped on the IP that is a netcat service that will listen to a specific port. So the load balancer probe it, and then it will realize that machine is not there anymore. And actually, the cluster had migrated this to the other side. So the load balancer will throw all the requests to the secondary node.
That's handled in Terraform.
Yeah.
It's just because that's different from local deployment.
Yeah, no,
Yeah.
this difference is covered there, yes.
Yeah, we have this extra resource.
So yeah, this netcat resource agent is not deployed for the other providers, okay? So it should be migrated already. So
Yeah, everything I think. Let's check here.
the demo gods are with a good humor today. So
If I go here, and if I okay, the second machine was already set as a primary. Okay, and this is a failover basically. Right now, if we want to register again SAP HANA 1 as a secondary, we have to do it manually. Okay,
yeah,
but we can put as well this auto register option as a true to make it automatic.
yeah. In a normal production system, now we expect some sysadmin running to see what happened with the secondary and to with the primary, and to reestablish again the cluster back. Okay. SUSE Manager?
Yeah. Last but not least, I want to show you how we could use this in SUSE Manager, okay? When we install the formulas, we will have these extra 2 salt formulas here. Maybe this is a new feature that you are not used to, but right now SUSE Manager is able to run salt formulas here. We have here some examples, and we have created the formulas for cluster and HANA, okay? As I said you before, they are independent, so if we want to use only HANA, we can only use HANA. And the same for HA. And this is how they look like. And basically, they mirror what we put in the pylars files, okay? And it's exactly the same. If you remember how the pylar files were composed, we need to put the same information, just that here we have a form that SUSE Manager understands, and it will deploy the same salt execution that is used in Terraform, okay? And basically that's it. We can put here all of the nodes we want. If we want to have the secondary, we can have it. We can put the system replication however we want. If we want it, if we leave it just to none, we don't have system replication in this node. And this is for HANA.
Yeah. Well, it's important to notice that it only covers the salt part, so the infrastructure needs to be prepared by SUSE Manager itself, okay? And this is not yet shipped together with SUSE Manager because, as I mentioned, we are under development and improvements, but this is already functional, and you can taste it going to our project and grabbing the package there. There is a package called SAP HANA Bootstrap Formula, and there is one called SAP HANA Bootstrap Formula-Suma that will provide the formulas and forms, so where you can use. They have exactly the same content, besides that one gives you the formula only, and the others gives you the SUSE Manager configuration. Okay.
Do you have a short YouTube video about this? Might be able to show me how.
Not
No,
in YouTube. We have several videos, but we can publish them maybe in YouTube as well.
Yeah, maybe we could prepare something. We don't have yet. Yeah. But most of those things are documented on the README of the project itself. And we are also available there if you have questions. Just open an issue or send an email or ping us on IRC. We can help you because one of the main things that we want to receive from you guys are feedback and to really make this useful. We want to reach a level where it's useful to put the systems in production. We know that this is a little bit utopic, but I want to cover something like 8–9% of your hard work and give you to really customize only what is really needed, okay? I think we have some slides still.
Yeah, we have finished the demo. So let's jump to the last part of.
Great. Okay, from the top.
SUSE.
Yeah.
Oh man. Yeah, LibreOffice. It is what it is.
Okay, I think we already covered, but of course we want to reach the application level, so not only HANA. We want to reach different HANA scenarios. We are working on the cost optimized. We have plans for scale out, more and more complex things. We want to include tests, so we want to have a test framework that will do the final steps to shake the cluster and automatically do the basic tests for you that usually I think you do manually nowadays. And we want to provide more integration, so OpenStack, enterprise storage. So we want to combine these with different offerings because we know that only these sometimes will not deliver you all you need for your production. And we also want to improve the day one. So this is covering the day two. This is covering the day one. You deploy it, fine. What about monitoring, managing, being alerted when problems occur? So we even have a prototype about our plans. So we didn't cover this on this session, but we have the idea to use time series data and collect real cluster information to improve alerts. And we are using tools like Prometheus and Grafana. So if you guys have interest, we have a prototype in the HA booth, but in a very early stage, so bear with us.
Okay. And last, some links here, if you are curious, if you want to check. Those are the projects that we use. The main one is this one that I have already shown you. And here we have the formulas, the lower layer, that is the API for SAP HANA, and some other extra projects that we are working on that are just side works for this.
This is where you can get the RPM packages. So we have an integration that everything that we change on GitHub goes directly there. So we always have up-to-date RPMs. Yeah, and I think the presentation will be available for download later. So and more documentation and the best practices that we have and are maintained. So mostly the things that we automate are basically the automation of what we recommend and what we maintain. Okay.
Okay.
And that's it.
That's it.
Questions?
We are on time. We have still 6 minutes.
Yeah, I wasn't that fast. So thank you everyone.